right, so this is Chapter 4, Section 6, Congruence in Right Triangles. Our learning objective is to prove right triangles congruent using the hypotenuse leg theorem. So we are picking up another theorem to use to prove triangles are congruent. So just to remind you, when you have a right triangle, the leg and the leg are the two shortest sides, and the hypotenuse is the longest side, and it is always opposite the 90-degree angle. That's forever in all right triangles. Theorem 4-6 says, if I have a triangle and it has the hypotenuse congruent and a side congruent, a leg, then I can say that the triangles are congruent. Alright, so to use the hypotenuse leg theorem, the triangles must meet three conditions. So you have to have two, what kind of triangles to use hypotenuse leg? Acute, obtuse, or right? Which kind of triangles do you need to use the hypotenuse leg theorem? So it has to be right triangles. If you have right triangles, the first thing you want to do is look at hypotenuse leg. Then if it doesn't fit, you can move to the other, like angle, side, side, that kind of thing. But if you have a right triangle, the first thing you want to test for is, can you use hypotenuse leg theorem? Triangles have what kind of hypotenuses? And I'll give you a hint. It's either going to be right or congruent. What kind of hypotenuse do they need to have? They need to have congruent hypotenuses. The hypotenuses need to be congruent, and then one pair of congruent legs. So you're looking at your triangles. You're seeing, do I have a right angle? Are my hypotenuses congruent? Hypotenuse congruent? And are my leg, do I have one pair of congruent legs? If I do, then I can use the hypotenuse leg theorem. Alright, so we're going to take a look at exercise 9 and answer some questions about it. Exercise 9 is developing proof, and we're going to complete the paragraph proof. We are given that angle A and angle D are right angles, and we're given side AB is congruent to side DE. We want to prove that triangle ABE and triangle DEB are congruent. So here's this little proof. So it is given that angle A and angle D are right angles. It satisfies the first condition for hypotenuse leg theorem. If angle A and angle D are right angles, then angle A and angle D, the measure of angle A and the measure of angle D are 90 degrees by the definition of right triangles. So if you say something's a right triangle, the next thing you usually do is say that they equal 90 degrees, just because that's... Okay, it's actually exercise, it's this picture up here. So angle PQR and angle XYZ are right angles. In exercise 9, how do the triangles in exercise 9 meet the second condition? They have congruent hypotenuses. Hypotenuses PR and XZ are marked congruent on the diagram. And then the third condition, one pair of congruent legs. In here it's PQ and XY are marked congruent on the diagram. All right, so let's see if we can apply hypotenuse leg to this situation here. If angle PRS and RPQ are right angles, and SP is congruent to QR, we want to prove these triangles are congruent. So we're given that angle PRS, all right, so we are given that angle PRS and angle RPQ are right angles. We're given that SP is congruent to QR. We're given, by the reflexive property, we can show that PR is congruent to RP. And then by the definition of a right triangle, triangle PRS and triangle RPQ are right angles, are right triangles. And then we can say by hypotenuse leg theorem, triangle PRS is congruent to triangle RPQ. All right, let's look at our reasoning question here. So your friend says, suppose you have two right triangles with congruent hypotenuse and one pair of congruent legs. It does not matter which leg in the first triangle is congruent to which leg in the second triangle. The triangles will be congruent. Is your friend correct? He says it doesn't matter which leg is congruent to the other. The triangles will be congruent. So the answer is yes. The two triangles satisfy the three conditions of a hypotenuse leg, so they're congruent. It doesn't matter which pair of sides of legs are congruent. As long as you have a congruent set of legs, you can use hypotenuse leg. All right, so let's look at this scenario. We're given that CD is congruent to EA, and that AD is the perpendicular bisector of CE. Now, we already have it marked that CD and EA are congruent. What do we do with a perpendicular bisector? What does a perpendicular bisector tell us? Not only do we get a 90-degree angle, but what else? What else does it tell us? Perpendicular is a 90 degree. What does bisector mean? Okay, so it takes a line segment and does what to it? Cuts it in half. So then the two halves of that line should be, and that cuts it in half, those two halves should be
Congruent.
congruent, yes. So this should lead us to two segments congruent. So that's what we're going to be looking to do in our proof, to show that these two segments are congruent because the perpendicular bisector cuts them in half. We have to show it because just because we say it doesn't mean it's actuality. And so let's start with our givens. What is the first piece of given information? CD is congruent to EA, so let's write that down. That's the first given piece of information. CD is congruent to EA. That's our first piece of information. What is our second bit of information that we get? Summer.
Because CBD is a right angle, and they're congruent in the definition.
Okay, so we're going to say, we're going to use our perpendicular bisector information to make our next statement. So we're going to say that CBD and EBA are right angles because that is the definition of a perpendicular bisector. It makes perpendicular or 90-degree angles. Okay, what's next, y'all?
Triangle CBD and triangle EBA are
Okay, got that? Number 3.
No, that was.
Yeah.
Oh, triangle CBD and triangle EBA are right triangles because they both of them contain a right angle, and that's the definition of right triangles. All right, what's next?
I'm just waiting for you guys to get the answers.
Okay, so CB is congruent to EB by definition of perpendicular bisector. If you are a perpendicular bisector, not only make a 90-degree angle, but you cut the line segment in half so you have two congruent sides. All right, so therefore, triangle CBD is congruent to triangle EBA by hypotenuse leg theorem. We got a hypotenuse, we got a leg, we got a 90-degree angle, so we can say that hypotenuse leg.